All right, so all this video is that you have to do now is I'm going to give you some key terms because we're going to start doing proofs, and when we're doing proofs, we have to justify every single step that we do, and we have to do it with definitions, theorems, postulates, or properties. We can't just say we're doing this and then give some long-winded explanation. You need to give me the exact definition or the exact terminology or the exact proof, or I'm sorry, theorem, and so on. So these are some important things that you need to be able to do. So in this video, I'm just going to have you must copy all these down and you must copy all these images. So when I check your notes, if you don't have all the images and copy down, you're not getting any credit. And this is going to be worth a lot of points, right? Because these are very important. You need to be able to refer back to these so you know exactly what they represent. All right, so the first one that we're going to go through is reflexive property. And this shows that a geometric figure is congruent to itself. So it doesn't necessarily need to be a figure like a triangle. It can be a line, a segment, a point, an angle, but it just shows that something is congruent to itself. So in one of the examples we've done so far a lot already is we know that this segment AC is congruent to itself because it's shared in both of our triangles. So this is one of the ways that it'll appear. And you will have to write it as segment AC is congruent to segment AC. All right, so this is one of the ways that you should already know by now because it's clearly part of both of our triangles. All right, the other way that it could appear is something that looks like this. So if I highlight these two triangles, and then I highlight these two triangles, and we're focused on triangle ADB and triangle BFC, if you notice, there is an angle that appears in both. This angle B appears in both. So sometimes it'll be an angle that appears in both of our triangles, and you would have to say that angle B is congruent to angle B. All right, so if you notice here, our triangles are overlapping. They're sharing both of the angles. The whole angle B is in both of them. So we would have to be able to say that angle B is congruent to angle B. All right, I'm going to pause this video and erase the one on the left-hand side and draw one more that you will see. So you must have all three of these drawn, and I would write notes saying that this is reflexive because it's shared in both of our sides. It's reflexive because the triangles are overlapping and we're sharing the angle in both triangles. All right, and then the last way that this could possibly appear, and if there's more than just these two, because I can't possibly give you every single way, I'm just going to go through the ones that will more likely that we will see. And then the other way that it could appear is, and again, when these triangles overlap, we could be looking at this triangle ABC. Right, then we could be looking at this triangle DAC. And if you notice, this segment AC is part of both of our triangles. So we would have to say that AC is congruent to segment AC. All right, so that's some of the ways that this could appear and some of the ways that you could see this. Let's move on to the next one. All right, the next one is the vertical angles theorem, and we've already talked about this, so we're going to go through this one very quickly, but it's formed when two lines intersect each other, and that the angles are always across or opposite of one another. So when we have these two segments, these two lines that intersect, it forms four angles, 1, 2, 3, and 4. And as we've already discussed in class, we know that these two angles are vertical and these two angles are vertical, the ones that are cross or opposite of each other. And the one thing that you have to know, that you should by now, is that they're always congruent. So we could say in this case that angle 4 is congruent to angle 2, and that angle 1 is congruent to angle 3. All right, this is something that we've already discussed in detail in class, so you should already know this one. All right, now the next word that you need to know is bisect. And bisect is when you divide into two equal parts. Now this can occur in two ways. We can bisect segments. So I can say that segment AC bisects segment DF. Now, when I say AC is bisecting DF, that means that this DF is the one that's being cut in half. So in this case, we can draw DF, and when we know that AC is bisecting it, that means AC is cutting DF into two equal parts. So in this case, we have AC. It is making two equal parts here. So now we can add this point E, because anytime two lines intersect, they create a point. And we're able to say that segment DE is congruent to segment DF. Right? The one thing that you have to be aware of for this is when AC bisects DF, AC is not being cut in half, but DF is, and it's creating two congruent parts. All right, and then the other way that this can appear is with angles. So I can say that segment AC bisects angle C. So if I then draw this angle, and let's just say that this is angle C here, and I draw this segment AC. Whoops. when we bisect the angle, it's bisecting this angle, meaning it's cutting it into two equal parts. So this angle is congruent to this angle. So let me just label these D and E so we can name our angles. So what we can say then is angle DCA, this angle formed here, DCA is congruent to the angle opposite or next to it, ECA. All right, but the main thing you have to know is that when we're bisecting, we're cutting it into two equal parts. Sometimes we'll be bisecting a segment, sometimes we'll be bisecting an angle. All right, the next one, definition of a right triangle, you all seem to notice as well already, but it's a triangle with a right angle. Now you might think that why do we need to say this, but in proofs you need to explain every single thing that you do. All right, one of the things I always say in class is treat me like I'm dumb. Treat me like I know nothing that's going on, but if you're giving me definitions and theorems, I can look them up. If you're giving me these long-winded explanations, I could get lost in that. So at least if you give me definitions, there's something I can then look to. So if we have a triangle with a right angle, what you'll notice is we can't just say HL right away. Because before we say HL, we have to describe that it is a right triangle. So what you will say, let's just say ABC, you will say triangle ABC is a right triangle. And then your justification, your reasoning for it will be definition of a right triangle. All right, so but what you need to know is that it has a right angle, and we know that this has a right angle because of that square in that corner. All right, this we will discuss in detail. It'll make more sense once we start going through some proofs. But you just have to realize that you must use this definition of a right triangle. That's why I need you to have it written down, because all these things that you're writing down, you will be using continually. All right, the next one that you might also think is very easy, definition of a right angle. Well, what is a right angle? It's an angle that forms 90 degrees. So if I give you this here and put ABC, we could say that angle B is a right angle. And why? Because it forms 90 degrees. All right, but it's just something that you guys will have to use throughout. And then we have one more, and then that's it for this video. All right, now the last one, midpoint. We've already discussed midpoint when we're given two endpoints, and we can use the midpoint formula. But now you're going to have to use it a little bit differently, but it's still the same thing. But it's a point exactly in the middle of a segment, creating two congruent segments. So the way that you will see this is we would say A is the midpoint of BC. So on your image, you would have BC, and we're saying A is the midpoint. So everything I'm drawing in red now, you must be able to apply. Once you see it's the midpoint, we can put these two tick marks because I know that we create two congruent segments. And then you would have to be able to say that BA is congruent to AC. All right, that's the statements that you'll have to be able to make, and then I'll explain how we can justify that in class. All right, so everyone must have these terms written down. You must have these definitions written down. You must have all of these examples written down if you want to get any credit for this video.